Welcome. We're going to focus on the standard form for a linear equation. Standard form. You are used to, pretty much everyone is at this point, a slope-intercept form like that. However, we're going to rewrite it and change it and put it into the standard form. And the standard form is where the x term comes first, then the y term, and on the other side, the equal sign is a constant. And there are three rules. One of them is the correct order, has to be the x term, then the y term, then the constant. And then next, the coefficients all have to be integers. That means not fractions or decimals. The third thing is that the first one, a, cannot be negative. This is the math way of saying that, greater than or equal to 0. But it cannot be a negative. If it is, you have to multiply every term by a -1 or divide every term by a -1 in order to make the a positive. The other ones can be negative, but not the a. Now, let's take this one, and we're going to put this in the standard form. So there are actually two ways to do it. First way, I'm going to take the denominator and I'm going to multiply everything by 5. So this is what it looks like. I'm going to multiply this side by 5. I'm going to multiply the other side by 5. But that means I'm doing distributive property. So what I get is 5y equals 4x plus 60. And that's important, recognizing you have to multiply to the other thing in this on the right side as well. Now that I have that, I have done the first thing or one of these things where they are all integers. Now I am going to need to move the 4x over to the other side so that I can put it in front and have the correct order. So that takes care of the correct order part. However, the a is a negative. So if we just divide everything by a -1 or multiply everything by a -1, we will get 4x minus 5y is equal to -60. And that is the standard form. It meets the three criteria above of having the correct order, only integers, and that the first term has to be a positive. So you can graph from this by making a table of values, usually. It is the same actual thing as this is here. The slope-intercept form is just another way to show it. All right. Here's another one. Let's take a look at this one. Now we're going to do the same thing. Oh, now this one I'll do with a second method. The second method for doing it is to not multiply by 9 first, but rather subtract 8 over 9x on both sides. Then that means I'll have -8 over 9x plus y is equal to -2. Notice I am careful to put the x in front of the y term. If I put it after it, made it y minus 8 over 9x, I might forget later to change it by putting the x in front, because the x is supposed to be in front. Now at this point, I'm going to multiply both sides by 9. I could choose, if I wanted to multiply by -9, so I get rid of the negative, or I can do it as a separate step afterwards. Right now, I think I'm going to leave it this way. So 9 times 9 means that, or 9 times -8 over 9 means I'll have a -8x. And then the 9 goes into both of these things, so it'll be 9y. And over here, -18. Now, at this point, I am now going to divide or multiply by -1 so that this one here becomes a positive. And that's going to make it 8x minus 9y is equal to -18. Oh, 18 or positive 18? Let's think about it. I multiplied by 9, that made it -18. I'm dividing by a negative. It looks like it'll be a positive 18. Okay. Always worth it to double check and think about negatives. All right. Now down here, we're going to look at a different way to graph these equations. We're using the standard form, right? We're not, and we are going to graph them down here too. What we're going to do is we're going to find the x and y intercepts, which is pretty easy with the standard form. The x-intercept is the place where the line is going to cross the x-axis, and the y-intercept is where the line is going to cross the y-axis. So if we find those 2 points, we can draw a line between them. Now, every single point along this line, the y is 0 because it's y equals 0, and the x is whatever the x is. On the up and down vertical line along the y-axis, for that one, the x is always 0, and the y is what will change every time. So we're going to find those two. So I will do the x-intercept here, and that means I am trying to find the number that goes for x when the y is 0. I'm going to do the y-intercept here, and that's when the x is 0, and we're trying to find the y. Well, the fact that the y is 0 here, and the idea then is we'll put it into that place. So we have 4x minus 3 times 0 is equal to 18, which is 4x equals 18. And then when you divide both sides by 4, 4 goes into 18 4 times, with 2 left over, which is 1/2 or 4.5. So your preference there, but I'm going to use the decimal. Okay, 4.5. On the other one, okay, so actually for graphing that, let's put that. That means that 1, 2, 3, 4, and about halfway. That means there's a point right here. Now on the other one, we have 4x minus 3y is equal to 18, but the x is what's going to be changed. The x is going to become 0. So I'm going to put 0 there. And that means negative 3y is equal to 18. And when we divide both sides by the negative 3, y is negative 6. Okay, so that means that number would go here. And we can graph it 3, 4, 5, 6. And that allows us now to make a line through them. And we have successfully graphed that line. But it required finding the x-intercept and the y-intercept. There's another one over here too. Stop for a moment, pause the video, do it yourself, and then come back when you're done to see if you're correct. And I'll start talking again very quickly. All right, I'm going to do the same thing here. This time I'll find the y-intercept on this side and the x-intercept on this side. It doesn't matter as long as I find the correct intercept. So on this one, that means the 8x will be a 0. It becomes negative 5y equals 36. So y goes into that 7 1/5 or 7.2. Ooh, but it's negative, so I need to actually do that with it. Let's do that. Negative 7.2. That's it. Yep. So that would go here, or I'll write it down underneath here, 0 and negative 7.2. And that's way down here, somewhere like about there, just past the negative 7 line. On the other side, the y will be made 0. So what we have is 8x equals 36. 8 goes into 32 4 times, which is half, so x is equal to 4.5. Sort of like part of the other problem, just a different way to get to it. So 4 and a half. 1, 2, 3, 4 and a half. And then we'll make a line for that. Okay. Oops. It's not quite working, but maybe it will this time. Oh, I didn't mean to do it red. Let's do it in black, but that's okay. Okay. Hold on, let me clean this up here. Okay. So that's the line for this one. And the intercepts are 0, negative 7.2, and 4.5, and 0. Let's make a table. So for a table, we have a number of choices of what numbers to put in. You should always put at least 3. So I want to graph this. 0 is always a great number to use, but let's use a couple of other numbers. I'll go up above it with, say, a 2, and down below it with, say, a negative 3. Just come up with something. So now, if I put first the 0 in for x, that means it's 2 times 0 minus 5y equals 15. Divide by the negative 5, because that's 0 down. It's negative 3 for this. Now on the top one, I'll do 2 times 2 minus 5y equals 15. That's 4. If I subtract 4, I get negative 5y equals 11. Y is equal to negative 11 over 5. A difficult one. Let's see what that would be. 5 goes into 10 twice and 1 left over, so that's 2.2, and it's a negative 2.2. Now let's do the last one. So 2 times negative 3 minus 5y equals 15. That's a negative 6, so I'm going to add 6 to both sides. Negative 5y is equal to 21. 5 goes into 21 4 times, if I divide it, and 1/5 left over, or 0.2. So we have here, oh no. So what we have now is a line. Let's go ahead and graph it. So 0 and negative 3, 2 and negative 2.2, a little bit, and negative 3 and negative 4.2. Ooh, now something looks weird, which is the idea here. Let's see what might be wrong with this. So it's the 2, okay, and 4.2, and negative 2.2, negative 1, negative 2.2, 3. And I think it will make close enough of a line. At first I thought it didn't look like one, but it actually is, because of how I put my dots. It doesn't look like it's right, but it actually is. Okay, that helps to see it better. So we've graphed that one by making a table of values. Now let's look at this one, and we would do the same thing. We'd make a table of values, put 0 in the middle. I'll put negative 2 and 4 just to be different on it. So if I put 0 in for the x and I divide by negative 4, I get negative 4.5. So that's the y-intercept, 4.5. If I put negative 2 in here, 3, negative 2, negative 4y equals 18. Negative 6 and added, it becomes 24. This becomes a negative 6. Okay, so this is the function of x, and this is x. Okay, oh, no, it's not. Oops, I have it wrong. Watch out. Let me fix that. This one is always x. This one is the result, and f of x means the function, which is the result of using the x in the equation. With a 4, it comes to negative 1.5. Calculated that before to speed things up here. So that means if the x is 4, we'll go to negative 1.5, which is about here. Negative 2 goes down to about negative 6. 3, 4, 5, 6. good. This one is not an issue with putting it in a straight line. Reasonable. That gives some idea now of graphing by doing a table, finding the x and y intercepts and graphing with that, and then simply knowing the names of the most important formulas or linear equations that we use right now. That's all. Thank you very much for listening and for watching.